Hello, my name is Saleh Sufia from class 15. Today I'm going to present about acid, base and salts. Okay, let's see the contents. The first one, I'm going to talk about definition of acid and alkali. The second one is pH value of acid and alkali. The third one is strength of acid and alkali. Next one is standard solution, and lastly is neutralization. Let's go for the first subtopic, which is definition of acid and alkali. What is acid? Acid is a chemical substance that ionizes in water to produce hydrogen ions, H+, while alkali is a chemical substance that ionizes in water to produce hydroxide ions. What is the difference? The difference is acid will produce hydrogen ion, which is H+, while alkali will produce hydroxide, which is OH+. Acid has three substances, which is monoprotic acid, diprotic acid, and triprotic acid. Monoprotic acid, as for example, is HCl. Diprotic acid is H2SO4, and triprotic acid is H3PO4. Why the example is like that? Okay. Hydrochloric acid only has one hydrogen, which is HCl, while diprotic acid has 2H hydrogen ion, which is H2SO4, and triprotic acid has 3 hydrogen ion, which is H3PO4. We can determine the monoprotic, diprotic, and triprotic by looking at the hydrogen ion. Okay, the next one is alkali. It is base that's soluble in water, for example, potassium hydroxide and sodium hydroxide. Potassium hydroxide is KOH and sodium hydroxide is NaOH. The next subtopic is pH value of acid and alkali. What is actually pH? pH is the logarithmic measure of the concentration of hydrogen ions in an aqueous solution. How to determine pH value of acid? We use formula of pH equal to negative log in bracket H+. H+ in bracket is the concentration of hydrogen. Let me give you an example. For example, calculate the pH value of nitric acid HNO3 with 0.5 mole Dm-3 of hydrogen ion H+. Okay, we see that in the question it gave us the concentration of hydrogen ion, which is 0.5 mole Dm-3. We can use the formula pH equal to negative log in bracket H+ and substitute the 0.5 into the H+, because H+ is the concentration, right? And then use calculator and press the log and bracket 0.5. Do not include the negative first, because the next step we can include the negative, because if we include at the first calculation, it will give us different answer. So press the log and bracket 0.5. We will get negative 0.301, and then we will multiply the negative with the negative 0.301. We will get positive 0.301 for the pH value of nitric acid. Okay, the next one is the concentration of hydroxide ion that is used to calculate the value of pOH of an alkali. Okay, it gives us different formula for hydroxide, which is for alkali. It gives us two, which is the first one is pOH equal to negative log in bracket OH negative. The next one is pH plus pOH equal to 14. As we know, the value of acid, pH acid, and the value of pOH alkali will give us 14. Okay, let's look at the question. The first question is calculate the pOH value for sodium hydroxide solution NaOH with 0.1 mole Dm-3 of hydroxide ion. It is the same as acid, the example of acid, which is they gave us the concentration for alkali 0.1 mole dm negative 3. So we substitute the 0.1 into the bracket of the OH negative. So press the log and 0.1, we will get negative 1, and then multiply it by negative, we will get pOH value is 1. Okay, let's look at the second example, which is calculate the pH value of potassium hydroxide that has 0.01 mole dm negative 1 hydroxide ions OH negative. Right now, they want us to calculate the pH value, not the pOH value, right? Okay, we use the first formula, which is pOH equal to negative log in bracket OH minus, because they gave us the concentration of potassium hydroxide, which is 0.01, and then we substitute into the OH bracket negative log in bracket 0.01, then press log, multiply with 0.01, we will get the negative 2, and then multiply negative with negative 2, we will get the pOH value is 2. Right now we want us to find the pH plus pOH, we will get 14. So 14 will minus with pOH, which is we get 2.00, right? So 14 minus with 2.00, we will get 12.00 for the pH value of potassium hydroxide. Okay, let's go to the next topic, which is strength of acid and alkali. Acid have strong acid and weak acid. Same goes with the alkali, which is strong alkali and weak alkali. Okay, what is strong acid? Strong acid is acid that ionizes completely in water to produce high concentration of hydrogen ions, H+. Okay, for example, HCl, because all molecule and hydrogen chloride dissolve in water ionize completely. When it ionizes completely, it will produce as high concentration of hydrogen ions, which is make it as this one is weak acid. It will only ionize partially in water to produce low concentration of hydrogen ions, H+. Okay, for example, is ethanoic acid, weak acid, because the molecule of ethanoic acid ionized partially in water, which is only part of the hydrogen will be ionized and part of them will stay as it is. Okay, let's look at the strength of acids. It is the same. It has strong alkali and weak alkali. Okay, for strong alkali, it will alkali that ionize completely in water to produce high concentration of hydroxide ion. It is the same, but this one is for alkali. For example, is NaOH, sodium hydroxide, is strong alkali because it undergoes complete dissociation when dissolved in water. What is dissociation? Dissociation is ionization. Then the next one is weak alkali, which is alkali that ionizes partially in water to produce low concentration of hydroxide ions, OH negative. For example, ammonia, that is weak alkali because the molecule of ammonia ionizes partially in water. Only part of the hydroxide ion will be ionized. Okay, let's go to the next subtopic, which is standard solution. Standard solution is a solution with known concentration. Okay, we can know the standard solution by experiment, which is the first one is preparation of a standard solution from a solid. The second one is preparation of a standard solution by diluting aqueous solution, and then they give us the formula, which is M1 V1 equal to M2 V2. M is the number of mole, and then the V is the volume. Okay, it is equal, right? So the number of moles of solid before dilution, which is M1, equal to number of moles after dilution, which is M2, is equal. During dilution water that is added to the aqueous solution will alter the concentration of the solution, but it will not alter the number of moles of solute contained in the solution, which is the number of moles will not be different from the before we dilute it. Okay, let's go for the next subtopic. The last one is neutralization. What is neutralization? Neutralization is a reaction between an acid and an alkali to produce salt and water, which is for the equation is acid plus alkali produce salt and water. For example, the reaction between nitric acid with potassium hydroxide to produce potassium nitrate solution and water. Nitric acid is an acid and potassium hydroxide is alkali. Then it will produce potassium nitrate, that is salt and water. And then for equation, it will give us HNO3, which is nitric acid, and KOH, as we know as a potassium hydroxide, will produce potassium nitrate KNO3 plus H2O. That's all from me. Thank you.